Hi, hello, welcome back to our channel. Today we are going to discuss about previous year's Eamcet problems, and the chapter name is the current electricity. Look here, first problem what they have given. A circular wire has current density J equals to 2 into 10 to the power of 10 ampere per meter square into R square. They have given as a function of that distance, where R is the radial distance out of the wire. Radius is how much? 2 millimeters. The end to end potential applied to the wire is 50 volts. How much energy is converted to thermal energy in how much time? 100 seconds. So the given data is, what is the given data here? J value they have given here. J equals to 2 into 10 to the power of 10 ampere per meter square into R square. And here R equals to radius of this one is how much? 2 into 10 to the power of minus 3 meters. Potential also they have given, time is also they have given. We have to find out the how much work energy is converting into thermal energy. Thermal energy and this one both are directly proportional to each other. So W equals to H equals to, but here you look this sphere, see how much distance we are starting from the center. That radius is how much? R. In between they have given that current density is smaller. So in terms of smaller they have given the current density. So here work done equals to, you know that W equals to VQ. From this you can write it, instead of Q we are writing IT also. IT also we are writing. Then V equals to, instead of I equals to current density equals to current per unit area. Then current equals to current density into area into T we are writing. So instead of this V is V only, instead of Q what we are getting? JAT into dr. With respect to distance it is changing. Then we have to substitute potential, and this is the radius, this is the small r square. Then circumference of this one is 2 pi r, and this time is the 100 into dr. After simplification, integration of r cube, what is the formula? R to the power of 4 by 4. Then instead of small r we should apply the upper limit capital R. Finally you are getting that answer is how much? Pi by 2 into 10 to the power of 4 into R to the power of 4. So here pi by 2 into, but radius also they have given 2 into 10 to the power of minus 3 meters. So this is R square, R to the power of 4 means we are getting 16 into 10 to the power of minus 12 into 10 to the power of 14. Finally our answer is how much? It is converting into thermal energy 800 by joules. This is looking big, but simple logic is there. We have to remember two things for this, that is the work done and this current density relation. Then we are substituting and finally we should find out that answer. Then we can go through the second problem. Our second problem is the resistance of, they have given like this, the resistances in following circuit are R1, R2, R3, all are having that 6 ohms. 6.0 means 6 ohms only. The electromotive force of the battery is 12 volts. When switch S is closed, the potential across the resistance R1 is changed by an amount. Actually the given circuit is like this. The given circuit is like this. See what they have given here. They have given like this. Original circuit is like this. Total how many resistances are there? There are 3 resistances. This is R3, this is R1, this is the R2. Beginning what happens? Switch is opened. Then potential is we have to find out. Then afterwards switch is closed. We have to find out the potential. But the question is what? Change in potential. Look here, when the switch is opened, no need of considering this part. So resistance of these two are in series. 6 plus 6 how much? 12 ohms is the current resistance and 12 volts is the potential. Then current equals to I equals to V by R. So V equals to how much here? 12. So 12 by 12 equals to, we are getting that how much current? 1 ampere. When you know the current, easily you can able to find out the potential across this one. V equals to IR from the Ohm's law. So 1 into 6, we are getting that 6 volts is the potential across the R1 when the switch is opened. Now the switch is closed. Look here. Then immediately these two are in parallel. So parallel means 6 by 2, how much? This is the 3 ohms. 3 ohms, and this is also 6 ohms. 6 plus 3, 9 ohms. When effective resistance is 9 ohms and current potential is how much? 12. Then total current is how much? 4 by 3 amperes. This is the 4 by 3. Now this 4 by 3, this is 4 by 3, but here 4 by 3 is divided into two equal parts. Why? This is also 6 ohms and this is also 6 ohms. Half of this one what we are taking? 4 by 3 divided by 2 means you are getting 2 by 3 amperes. So 4 by 3 is divided equally. So potential across 6 ohms. Now we have to find out the potential across the 6 ohms as usual. 2 by 3 I into R from the Ohm's law. Here you are getting the 4 volts. Here you are getting the 4 volts. See, 2 by 3 into 6. Then but the change in potential means we have to take it 4 minus 6 is the minus 2 volts. So our answer is how much? Minus 2 volts. Then come to third problem. Third problem is very easy. Look here. What problem they have given. See, there are 4 bulbs are there of power 100 watts, 200 watts, 500 watts, 1000 watts. Among these, whose filament has high resistance, assuming same voltage of the source. Same voltage of the source means all are connected in parallel. In parallel, what is the relation between power and resistance? Parallel, we can say that V square, V is the constant. Then power is inversely proportional to R. So more power, less resistance. But the question is which is having the more resistance means less power. Among all these, 100 watts bulb is having very less power means it has a high resistance. This is very simple problem. Easily you can able to remember here. But the logic is here same potential means they are connected in parallel. That is the main thing. Then our fourth problem is, they have given that fourth problem, meter bridge experiment. See, a meter bridge, two gaps in the metallic strip are connected by 3 ohms and 9 ohms resistance. What should be the value of the shunt that is connected across the 9 ohms? At the time shift of the balancing length is how much? 25 centimeters. So first we have to find out what is the balancing length here. See, we can go through this formula. 3 by L. Instead of X we are taking 3 by L. See, balancing length, you know that X by R equals to L1 by L2. Otherwise one side we are taking the resistance, another side is the balancing length. Anyway, first resistance is 3. That length we have to consider L1 is L. Then second balancing length, if you know L, that is 1 meter scale means 100 centimeters minus L. After that, after simplification, our balancing length is how much? 25 centimeters. But in second case, we are connecting, actually meter bridge is like this. See, now one more small S is connected across the parallel. Because of that reason, already 25 is there. Now it is shifting to how much? 50 centimeters. So you can take it as usual, same here, 3 by 50. But second one is changing. Both are in parallel means 9S by R1, R2 by R1 plus R2 by 50. 50, 50 cancel. After simplification, that shunt resistance is how much? 4.5 ohms. So you should do the cross multiplication, then you can able to find out the shunt here. So this is also very easy, looking very big. Then our fifth question is, a conductor of length 100 centimeters and area of cross section is 1 millimeter square carries a current of 5 amperes. If the resistivity also they have given 33 into 10 to the power of minus 8, then electric field across the conductor is, look here this problem. We should find out the intensity of electric field, but the given data is they have given the length of the wire, area of the wire, current they have given, and specific resistance or resistivity also they have given. So one simple formula is there for this, that is the, look here, this is the given data. Intensity of electric field, you remember that, that is the current density into specific resistance. Current density, what is the formula? I by A into rho. I is the 5, this area is the millimeters, means we should convert into meter square, means we are getting the 10 to the power of minus 6, and this value how much? Specific resistance 3 into 10 to the power of minus 8. After simplification we are getting that intensity of electric field is how much? 0.15 Newton per coulomb or volt per meter also we are taking here. Then our next question is based on that Wheatstone bridge. It is very simple answer. Look here, the circuit diagram they have given like this. Bridge is balanced, they said. Bridge is the balanced, means what expression you are getting. When the bridge is balanced, means current passing through the galvanometer is equals to 0. Simply we can write it, this one by this one equals to this one by this one resistance. R2 by R4 equals to R1 by R3. But based on the given data, based on the given options, we should give that answers. So here it should be right. Look here, R2 by R4. R2 by R4 equals to R1 by R3. But it is matched to the our first option. It should be right. R2 by R1 equals to R2 by R1, cross multiplication equals to R4 by R3. So this is the correct option, first option. Then our seventh question also very easy. Based on this, see, they have given two wires. A cylindrical wire P has how much resistance is there? 10 ohms resistance is there. A second wire Q has length and diameter half of that first one. If the material, both are having the same material, first one is the steel, means second one is also steel. If first one is the copper, means second one is the copper, means which is constant? Specific resistance is constant. Then what we have to find out? The resistance of the wire Q we have to find out. But they have given the resistance of the first wire is how much? 10 ohms. It's very easy. Look here, we have to take the ratio of relation of that resistance and length, because specific resistance is constant. So R is directly proportional to length and inversely proportional to area. So we can write it R1 by R2 equals to L1 by L2. Instead of area I have taken diameter or radius, anything, R2 by R1 whole square, because it is inversely proportional to each other. Instead of area we are taking diameter square. Then R1 by R2, half of the length. L2 becomes to half of the first one, means L by 2, LL cancel. But here R2 is half, means R by 2 divided by R, RR cancel. After simplification, they have given R1 is the 10 ohms by R2. This is what? 2. 2 into 1 by 4. After simplification, our answer is how much? 10 into 2, 20 ohms. 10 into 2, 20 ohms. It's not 7. After simplification, we cut like this. Then our answer is how much? 20 ohms. Then our eighth question is like this. One circuit they have given. Find the current in the circuit. For finding the current, we have to know about the equivalent resistance and the potential also. Here two batteries are there. One is the 20, another one is the 10. See, positive is giving to positive, negative is giving to negative, means we have to subtract that one. So 20 minus 10 is how much? 10 volts is the potential. Now you look here, these are parallel to each other. Equivalent resistance 100 by 2 is the 50 ohms. And these two are what? These two are in series. 100 plus 100 how much? 200. So these two are series to entire combination of this one, means total effective resistance is how much in this case? Effective resistance is 250 ohms. Look here, these two are in series. Effective resistance is 200. These two are in parallel, that two identical. So each one resistance 100 by number of resistors is how much? 2 by 2. This is how much? 50. But this one is series to this one, means 250 ohms resistance is there, and effective resistance is the 10 volts. Then from the Ohm's law, I equals to V by R. Our answer is how much? 0.04 amperes. Then our next question is ninth question. What they have given? They have given that a conducting wire of cross section area 1 centimeter square. So you see this one, this is also same model. We can go through the 10th one. That is they have given the circuit is like this. This is the circuit, and the question is what we should find out. We have to find out the total current supplied to the system is the total current supplied to the system. They have given like circle here. They have given circle. From the circle, how many resistors are there? 4 resistors are there. So we can modify that circuit is like this. See, from A, B, we are taking from A to B. A to B. See, ladder method also we can take. This is the A and this is the B. From the A, how many resistors are started? 2 ohms, 6 ohms and 3 ohms. Directly 3 ohms is started at A and ending at B. So this resistance is how much? 3 ohms. But these two are parallel. Commonly it is giving series to this one. So 6 into 2 by 6 plus 2. After that this is also how much? 1.5 plus 1.5 how much? 3. Now these three both are in parallel means 3 by 2 is the 1.5. Then I equals to V by R means, so V equals to how much? 6, and that resistance is the 1.5. After simplification, current passing through the circuit equals to how much? That is the 4 amperes. That is the 4 amperes. Now you look here, easily you can understand. Here battery is there. Across the battery I am taking one is the A. So this is the A. From A how many started? 1, 2, 3. 3 are started. But this third one is connecting direct to the from A to B. But these two are started from A, but commonly it is giving to the 1.5. So we can modify the circuit and we should solve like this one. Then our next question is like this is also very simple answer. Look here, the resistance of the wire is how much? 20 ohms. If it is stretched means immediately you have to remember that for stretched wire means which is constant, volume is constant. Look here, resistance formula is rho into L square by V. So but whenever the wire is stretched, immediately you don't think area is constant, you should think volume is the constant. In terms of volume, we can write the resistance formula R equals to rho into L square by V. So it should be right R1 by R2 equals to L1 by L2 whole square. But already they have given R1 is how much? 20 ohms. After simplification, our answer is the 120 ohms. Already I made that crash course, many chapters, almost 98% is over. You follow that. After that, once you can go through the these previous years Eamcet problems, it is very benefit for you. So thoroughly daily you should practice the formulas and chapter wise problems. Only limited time is there. So all the best, prepare well and do the hard work. Thank you everyone. Please subscribe my channel and share my channel to your friends.